about the accuracy of laboratory equipment, as well as how to correctly use some of them to avoid systematic
First, we're going to talk about the three most common types of funnel. The powder funnel is used to transfer solids as it has a wide and short stem, thus it does not clog easily. The narrow stem funnel is used in the transferring of liquids into smaller necked glassware. Buchner funnels are made of porcelain and include a plate of perforated porcelain. These are used for filtration under low pressure with a Buchner flask. This funnel is used in collecting solid precipitates.
In order to collect the solid precipitate, the Buchner funnel is used with a vacuum, filter flask, and rubber adapter. The first step is to clamp the filter flask. After the filter flask has been clamped, fit the flask with a rubber adapter. And then place the Buchner funnel on top. Filter paper is used to completely cover the holes in the Buchner funnel. Attach the hose from the vacuum to the filter flask. Next, call a TA to turn on the vacuum. Pour the solution containing the precipitate into the Buchner funnel. After the precipitate has been collected, call a TA to turn off the vacuum and disconnect the vacuum hose. Collect the precipitate from the filter paper.
Now we're going to talk about pipettes.
A volumetric pipette is used to transfer liquids from one source to another. It has a single graduation that allows it to transfer one specific volume accurately. There are many different sizes of volumetric pipettes. To pull up liquid, roll the wheel towards you, and then to expel liquid, roll the wheel away from you. Glass pipettes are disposable pipettes that require a non-disposable bulb. They are much easier to use for solvent transfer than volumetric pipettes. To pull up liquid, squeeze the bulb, and to release liquid, squeeze the bulb again.
A pipettement, also known as a micropipette, measures and transfers small volumes of liquid. They also come in different sizes that measure different ranges of volumes. There are two types in our lab, P1000, which has a range of 100 to 1000 microliters, and P200, which has a range of 20 to 200 microliters. When using our pipettement, check the top plunger button to ensure that the correct pipettement is being used. Rotate the volume adjustment knob until the digital indicator reaches the desired volume. Firmly place a disposable tip on the shaft of the pipettement. Next, depress the plunger to the first stop. Hold the pipettement vertically and immerse the tip into solution. Release the plunger slowly. Withdraw the tip from the solution. Place the tip against the side of the wall of the receiving tube and push the plunger down to the first stop. Wait a couple of seconds and then depress the plunger to the stop in order to expel any solution in the tip. While the plunger is still depressed, remove the pipettement from the tube and allow the plunger to return to its normal position. Once done pipetting, discard the disposable tip by pushing the ejector button.
Now we're going to talk about other types of glassware. The beaker is a simple container for stirring, mixing, and heating liquids commonly used in many labs. They are generally cylindrically shaped with a flat bottom. Most have a small spout or beak to aid in pouring. Beakers are available in a wide range of sizes, from 1 milliliter up to several liters. Beakers are often graduated, that is, marked on the side with lines indicating the amount of volume contained. These marks are not intended for obtaining a precise measurement of volume, but rather an estimation. They are accurate to about 5%.
The Erlenmeyer flask is a type of laboratory flask which features a flat bottom, a conical body, and a cylindrical neck. It differs from the beaker in its tapered body and narrow neck. The tapered sides and narrow neck of this flask allow for the contents to be mixed by swirling without risk of spillage, making them suitable for titrations. Such features also make the flask useful for titrating liquids. Hot vapors condense on the upper section of the flask, reducing solvent loss. Similar to the beaker, it can be used to approximate volume and is accurate to 5%.
A graduated cylinder is used to measure the volume of a liquid. They are generally more accurate and precise than flasks and beakers. Graduated cylinders are meant to be read where the meniscus lines up with the bottom of the graduated lines and is accurate by 1%. Typically, the capacity of graduated cylinders are between 5 milliliters and 2,000 milliliters. A stir bar or magnetic stirrer is a device that employs a rotating magnetic field with a stir plate, causing the stir bar to rotate in solution. A burette is used to deliver solution in precisely measured variable volumes. They are primarily used in acid-base titrations to deliver one reactant until a precise endpoint is reached. Before titrating, condition the burette with titrant solution and check that the burette is flowing freely. To condition the burette, rinse the inside of the burette with solution, then drain through the tip of the burette. Condition 2 or 3 times to make sure that the concentration of titrant is not changed by a stray drop of solution. To fill the burette, close the stop clock and fill using a funnel. Check the tip of the burette for an air bubble. To remove an air bubble, flick the side of the burette while solution is flowing. Once air bubbles are removed, take an initial volume reading. Be sure that the volume is read from the bottom of the meniscus and at eye level. Before starting the titration, make sure the burette is completely vertical. Deliver the solution to the titration flask by turning the stop clock. Make sure to swirl the Erlenmeyer flask as you are titrating. The solution should be delivered quickly until a couple of millimeters from the endpoint. The endpoint should be approached slowly, a drop at a time.